Hello students, the purpose of this video is to get you acquainted with some rules for differentiation. And in this video, we're just going to be talking about some shortcuts for calculating derivatives. So we're going to be looking at 4 different rules: the constant rule, the power rule, the constant multiple rule, and the sum and difference rules. And these are going to be super helpful to you. So the very first one is the constant rule. The derivative of a constant function is 0. So literally the definition says f prime of c is equal to 0. Let's think about why this makes sense. If I were looking at a function that was on a graph, so let's say that I had the line y is equal to 2, no matter what point I look at, the slope at each point on the line is equal to 0. And remember that derivative and slope are the same thing. So if the slope at each point is 0, then the derivative of that constant value also has to equal 0. Your second rule is the power rule. This is probably seen as one of the most helpful rules. So this says that f prime of x to the nth, meaning you have some function that contains a power. You can multiply that power to the front as a base value, and then you subtract 1 from your exponent value as long as your exponent value is a real number. So what does this look like? Well, if I had f of x is equal to x, then its derivative would equal 1 because the understood exponent on x is a 1, and so I'm multiplying 1 in front. So what's actually going on here is I'm multiplying 1 in front and doing subtracting 1 from the current exponent, which is 1x to the 0 power, which just equals 1, and that's how I get my slope value. If I had x squared, then excuse me, let me erase that. I wrote that incorrectly. If I had f of x is equal to x squared, then f prime would be move the 2 to the front, multiply, subtract 1 from the exponent, which is the first power. If I had x to the 4th power, I'm going to find its derivative by multiplying the exponent to the front, subtracting 1 from the current exponent, and that gets me 4x to the 3rd power. Let's say that I gave you something like 1 over x squared. That may be a little challenging to find in this format, but you can always rewrite that to x to the -2 power. We've learned our exponent rules. And now I can use my power rule to find my derivative, which in this case would be -2 x to the -3 power, because I'm subtracting 1 from -2, which gets me -3. And if I simplify that, that's -2 over x to the +3rd power. Same goes with having a square root or some type of radical. I can write that in its rational exponent form, which then makes it easy for me to use the power rule, and I end up getting 1/2 x to the -1/2 power, which I can simplify to 1 over 2 and then the square root of x in the denominator. So power rule, super nice, super helpful. We love it. Makes our jobs super easy. In the constant multiple rule, if f is differentiable and c is a real number, then the derivative d over d of x of c f of x is equal to c times f prime of x, where c is a constant. So all that this is saying is that you can take out your constant, find the derivative of your function first, and then multiply at the end. So we'll come across that a lot, especially when we're doing our homework. And then our very last rule is the sum and difference rule. The derivative of the sum difference of 2 differentiable functions is the sum and difference of their derivatives. And I would like to note that there's a mistake on this slide set. There should be a little tick mark there to represent the derivative of g of x. So for example, let's say that I had a function and its function was x squared minus 5x plus 7. So I have the combination of some sum and differences. I can actually find the derivative of each part. So I'm going to notate that as d over dx of my x squared, and then minus the derivative of my middle term, which is 5x, and then the derivative of my constant term, which is 7. And utilizing my power rule right here, that gets me 2x. Utilizing my power rule in the middle term gets me -5. Utilizing my constant rule gets me +0 for a final derivative answer of 2x minus 5. So super helpful, super easy. We love to utilize the sum and difference rule. Makes our lives very, very, very simplified. As always, if you have any questions or concerns, please don't hesitate to reach out, and I hope that you found this video helpful. Have a good day.